Welcome to this short video where we're going to be exploring Newton's third law and how we can apply it to a variety of situations that you might come across in day-to-day life, such as why this skateboarder seems to lose his skateboard completely from underneath him. Now, Newton's third law says that if one body exerts a force on another, then there's an equal and opposite force, called a reaction, exerted on the first body by the second. Now that can be incredibly useful, okay, and it's applicable to a lot of situations, and in most cases you won't even consider the second force.
Okay, so what we've got here is a surfer. Now the surfer has finished riding his wave and he's trying to fall safely off his board. So to do so, he wants to move away from the board. He's trying to move himself in this direction to the right. Now to do so, he must push the board to the left. As he pushes the board to the left, there is an equal and opposite reaction pushing him to the right. He pushes the board to the left, the board pushes him to the right. Now I'm just going to redraw that because the two forces are equal and opposite, so I want to get the two force arrows to be the same length, okay, so as I'm as accurate as possible. So the force on him to the right is equal to the force on the board to the left, and we'll watch this in action now. Now as we watch it, you'll notice that due to Newton's second law and the fact that the board is so much lighter than he is, it has a far smaller mass, the acceleration of the board is far greater than him, so the board will more or less shoot off to the left, whereas he just moves slowly backwards to the right.
Now this really shows the equal and opposite actions. Okay, the board moves one way and he moves the other, and we can see it again in this similar clip where he moves backwards and his board moves forwards, and then this one really shows it off nicely. Okay, you can see him falling to the right and him pushing the board away from him. Now the fact that the two objects move in equal and opposite directions is down to the Newton's third law. Now this is amplified in this case because the board is so much lighter than the skateboarder. It really does shoot backwards, and you can see just how far away the board rolled when he fell off. And let's just watch that again. Now I hope you're all feeling very sympathetic towards this poor gentleman. Now this slow motion clip of Daphne Schippers is really interesting. Off the start you can see her pushing backwards off the starting blocks, and the slow motion really emphasizes the leg drive pushing the floor backwards to propel herself forwards. Now we'll just watch the start again to show you the drive off of the start. Now in this next classic example we've got a bullet and a gun. Now Newton's third law says that the force forwards on the bullet should be equal to the force backwards on the gun, and this leads to the effect that's known as recoil. Now you can see the bullet exiting the gun again, but because the bullet is so light compared to the gun, the effect on the gun is almost negligible, and it's only after the end of this clip do you actually see the gun recoil backwards. Now finally, I really like this last clip. The simplicity of it shows Newton's third law in action, and yes, that really is a great pun. The skateboarder is driving the floor backwards to propel themselves forwards. So I hope you've enjoyed this clip or this video, and I hope that it's made Newton's third law make a little bit more sense.